All right, there's the beep. We are started. Okay, so in front of you, you have a square. How do you know that's a square?
It has all equal sides.
It has four corners, so this is a square. No. There you go. Yeah, it's the square because it's got sides of the same length and it's got corners. So this is a square. Really? That's a square.
Yeah, it's square.
That.
That is square.
The one up top, the drawing.
The drawing. The red drawing I just drew there. That's a square.
Yeah. And they're all equal.
Or a number is equal to a perfect square.
What is bad drawing?
Okay. I'll emphasize what I wanted you to get out of that, Craig.
Okay. No, that's not. Oh, yeah.
Oh, that's oh.
That's a square. Yes or no? No. Why? Why is that not a square?
Well, if you like move it like that.
Nadia.
Sure.
Yeah, it's leaned over. It's not got 90-degree angles. Cool?
Yeah.
Okay. So, now remember how yesterday we talked about how math started. You guys only know math as numbers because you have calculators and computers and everything, right? Back in the day, they didn't have any of those things. And they were the ones that noticed the patterns of numbers because there was nothing else to do. They didn't have a computer. They couldn't tabulate it. They did all of their math by experiment. And one of the things they noticed was when you make any shape, if you take the length and the width and you multiply them, you get the area inside. And you guys already know this. We talked about this yesterday, right? This is how multiplying fractions works. Yeah? So this was length times width, which in this case is 5 times 5, which gives me 25. Now where is that 25? It is inside here, 25. Okay? Now, this tells us that... You done? Okay. This tells us that a square has two measurements. There's the side and there's the area. Okay? The side is the square root. The area is the perfect, don't write perfect. The area is the squared number. Okay, and all that means is the side, when you multiply it by the same number, you get the square. That's kind of out of focus, isn't it? Or is it? Or is it just my old eyes? Shut up. See, my ears are fine.
Yeah.
That's better, yeah? Mm-hmm. Is it? Or was it just me?
No, that's better.
Okay. Everybody cool? Yeah?
Yeah.
Okay. So on this one, I want you to add 2 rows out here. It doesn't have to be perfect. Can you tell me the area of this thing that we just drew? How? Pardon me, Bryn? Yeah, length by the width, absolutely. Is that a square anymore? No. So length and width still works, but it no longer gives me a square. How would I have to fix this up so it gave me a square? I would have to add 2 more to the bottom and go all the way out to the sides. Now do I have a square? Do length and width work? Great. So what was the length? 7. What was the width? 7. What's the area? 49. Right? Everybody cool? So, that means 7 times 7, that's my area, equals 49. Which of those is the square root? The 7. This is the square root. There's the root, whatever it is. And if I multiply it by itself, I get the square. Is everybody cool with that? Okay. Now listen. This gets confusing simply because terminology. Square root, square. Square root, square. People forget which is which. Okay? The square root is the smaller one. The square is the bigger one when you're using whole numbers. Everybody cool with that? What are there more of? Square roots or perfect squares? It's kind of a trick question. In the universe, what is there more of? They're both infinite, aren't they? Because eventually you get up to infinity, and then you could square it and do infinity times infinity. You're still at infinity, right? So technically it's both. But in reality, which is there more of? You say perfect squares. Does anybody agree? Does anybody disagree? Is anybody just waiting for me to tell them the answer? All of you put your hands up. There you go. Of course there are more square roots. Why? What do you do with a square root to get a square? You multiply it by itself. Does every single possible number, can you multiply it by itself? Yes. So is every single number a square root? Yes. But every single number is not a square. Does everyone understand that? Let me give you an example. Can you multiply 1 by itself? 1 times 1. Can you do it? Yeah. So 1 is both a square root and a square. You with me? 2. Can you multiply 2 by itself? So 2 is a square root, isn't it? Because you can go 2 times 2. That makes 2 a square root, because the roots are over here. What's the square? 4. There's the square. Okay? We missed 3, didn't we? So right away, 3 isn't a perfect square, but 1 and 4 are. But 2 and 3 aren't. Picking up what I'm putting down? Can you multiply 3 by itself? Yeah. 3 times 3 is 9. So that's the next perfect square. It goes 4, then 9. 5, 6, 7, and 8 aren't squares. But are they square roots? Yes, because you can do 5 times 5, 6 times 6, 7 times 7, and 8 times 8. Everybody cool?
Yeah.
Every number is a square root. Special numbers are perfect squares. Got it? Okay. So since you already know that, we can fill this in super easily, yes? 7 squared, which means what? That actually means 7 times 7. What's the answer? 49. Come over here. That symbol means square root. So if I square root it, I get 7. So the root is the side length. Square root is side length. Square is area. Everybody cool? The squares are the bigger numbers as long as we're using numbers that are bigger than 1. If we get smaller than 1 into fractions, not mixed numerals, just fractions, then this rule changes. But we're not going to talk about that in grade 9. Everybody cool? Okay. So what's this guy's length? 4. So it's 4 squared. What's the area then? 16. Everyone got it? So 16 is the square. So you can square a number, but you square root a square. Right? This is why it gets confusing. So what goes here, the 4 or the 16? The 16. And that's 4, so the side length is 4. Everybody got it? Okay, fill in the rest of that chart. It'll take you a couple of seconds. Is everybody good? Yeah? Okay. How many people had to get their calculator out for 11 times 11? How many people waited until I wrote 121 and then wrote it down? Okay. Everybody good? I can move on to the next page? Okay. Now this next box here is so important for your understanding of further math, because math teachers talk about squares and square roots interchangeably, okay? And it kind of confuses you guys, okay? The square of a number, okay? This number, that is the root. So if you were going to take the square of any number, it is the number times the number. That looks like num times mum. It is the number times the number. Now, we don't write that in math, do we? What do we use in math when we're talking about any number? We use a letter. So it's also x times x, and it's also x squared. Is everybody cool with that? That's getting the square. The square root of the number is one of the side lengths if we draw a square. But it's also the factor that goes there. Does everybody understand what I mean by that? The square root is the thing that we are multiplying by itself. The square is the answer. Cool? Okay. And squaring and taking a square root are what we call inverse operations. Now, we've already talked about inverse operations, haven't we? What's the inverse of multiply? Divide. What's the inverse of subtract? Add. So you guys already know that divide and multiply are related, add and subtract are related. Well, square root and squaring are obviously related, because one goes one way, makes things bigger, one goes the other way, makes things smaller. Right? Okay. So now you should be able to fill this chart in. 4 squared is 16. So now flip it around. 4 squared is 16, so the square root of 16 is 4. 12 squared is, who knows their 12 times table? 144. So the square root of what? Square root of 144 is what? 12. Got it? Okay. Square root of 25 is 5, because 5 squared is 25. Cool? Square root of 100 is 10, because 10 squared is 100. Is everybody good? All right. Now, There's some blank space over here, and there's a reason for that. Let's say I have a perfect square. I'm going to give you a number. You have to decide if it's a perfect square or not. What makes it a perfect square? You just did 4 perfect squares. What makes these numbers perfect squares? They're all even. These ones, 25 is even? No. So it's not that they're even. What else? Yeah, you can get a square root from it. Okay? So I'm going to start with 64. Is that a perfect square? Yes. Why? Yeah, the square root of 64 is 8. Does everyone agree?
Yeah.
Now, how many square roots does 64 have? No.
Only one, right?
You want to say 1, don't you?
Yeah.
Because 8 times 8 is 64, yes?
Yeah.
So what you're saying there is 8 squared equals positive 64, correct? So 8 has 1 square root, agreed?
Yeah.
Not quite. You're halfway there. It has 2 square roots. What's 8's other square root? No, because 8 and 8 are the same thing. No. You got to think about this. We talked about it on the very first day. Half the numbers in the universe are what? Negative. So what's the other square root of 64? Negative 8. What? Check it. What's negative 8 times negative 8? 2 negatives.
All positive.
Positive 64. Cool? So we need to remember, and this isn't really for grade 9, that's just a gift to you. Because in grade 10, they will start talking about the negative square roots. Okay? So I'm giving you a gift, a mathematical gift. Unwrap it. I'll put it under the math tree. So the square root of 64 is really positive or negative 8. Everybody with me? But in grade 9, which one do we care about? Just the positive one. Cool? When this really is going to bite you in the bum is grade 11. In grade 11, this fact becomes absolutely important. Okay? But for grade 9, not at all. Just kind of a neat idea, neat thing to remember. Grade 10, oh yeah, I got to remember there's 2. Grade 11, oh my god, I can't do math unless you remember that there's 2. Cool?
Yeah.
Cool. What kind of sub you got?
I have something.
What kind of sub you got? Prime rib mel. How is that? I've been looking at it. Is it good? All right, I believe you. I used to work at Subway. I used to manage Subway. I was a sandwich artist. Back when you actually had to have some skill to make the sandwiches because they cut them in a U. Do you guys remember that? Are you old enough to have remembered that?
I do.
They used to cut the roof out of the sandwich and cut it in a valley so none of your toppings would fall out.
So it's like a hot dog?
Yeah, kind of like a hot dog, but then they would put the sandwich back, the roof back on the top. But then the stuff never fell out the sides. But then they changed and they started cutting it flat. Now your stuff falls out all over the place and Subway is disgusting and messy. But if you go to Subway and you say, can you cut it the old way? Nobody's worked there that long because it's a crappy job. Nobody remembers how to cut it that way. So they're like, what do you mean? I say, cut out the top. And they cut a circle out of the top like a hat. No! And I say, give me the bread. So they give me the bread and I cut it myself and I give it back to them. Now make my sandwich. They're like, that's so cool because they're all, your people's age that work at Subways now. Sometimes they tell me I'm not allowed to cut the bread. And then I say, well, then I guess you're not selling a sandwich, and I walk out. Sometimes if I'm really in a bad mood, I say, remind me to call the owner and tell them that you just lost them a $25 sub sale, because I'm always buying for my whole family. Right, I'm such a dink. I know. Right, I know. But who's right in a business?
Oh, I was there.
Customer. End of discussion. I want a U-gouge cut out of my sandwich. That's what it was called.
So it's like this way, you cut it like that.
Okay. This is that's the Subway bun from the side.
Yeah.
Okay?
Oh, he's trying.
Here's the bun from the roof. Okay, so this is the top view. So what you did was you cut along the top.
Oh, I get what you're talking
Okay?
about.
Now wait, this is the front view. Okay? So the cut would come along the top, and then you would cut down here and cut out a U shape so the bread had walls. And the toppings would all go in here.
You just fill
It's
it
like a taco.
Yes, it's more like a taco.
up. Yeah.
And it was awesome. If you go to Subway and there's an old person there, they might have worked there long enough to remember this. But I doubt it because they stopped doing it in like 2000. I wouldn't work at a Subway again. I might own a Subway again.
Oh.
But it's expensive. No.
Again, you own one?
That would be the only way I would work in a Subway again. So, back to business. So we are done all this, yes? This is what we just described. This is what we were just talking about. 25 perfect square, because there's two equal factors. 5 times 5, which is the same as 5 squared, yeah? But 24 and 26 aren't. Everybody cool? Okay. Yeah? All right, now listen. This chart, I will never give you guys a test. I will never base your grade on your ability to remember stuff. Do you know what I am saying? Like, I am not going to put a question like this on your test. Fill in this chart. I would not do that to you because some of you have better memories than others. That doesn't make you better at math. It just means you'll beat me if we put out the cards and play memory. You understand? This is not memory 9. This is math 9. But I do have this chart here because knowing this chart, if you actually memorize it, it will be very helpful to you in the future. Okay? So I quite frankly don't even care if you fill it in. But it will make your lives better. So I'm going to take the time to actually fill this in. It only takes a couple of seconds to do. And while I'm filling it in, you guys can talk amongst yourselves. Or you can fill it in. But this column right here is a real good column to know. It really helps to know all the square roots up to 100. You actually should know it up to 400, but I don't know how many of you would take the time to memorize that. It will make your life, like I say, infinitely easier as you go further ahead in math. But as you can see, it didn't take me very long to fill it all in. Remember, the big numbers are what? The squares or the square roots? The squares. And the smaller numbers are the roots. If you know these two columns up to 12, you're going to be in really, really good shape for next year's math class, especially if you are in Math 10 in September. Okay? You will be so far ahead of your buddies. Trust me. Because squares and square roots become more and more powerful as you go on further in math classes. So if you have them available to you, that's really good. It's kind of like your times tables, right? How easy is doing fractions if you have your times tables memorized? It's real easy. But if you have to think every time about how to find a common denominator and how to reduce fractions, oh, what divides into that? I don't remember. Then fractions are a super pain in the rump, right? But if you actually have your times tables memorized, it's a lot easier. Same thing here. Okay, so I'm going to leave that up for a second while I have my last sip of coffee, make sure everybody's got it, and then we'll carry along. Okay? Yeah, I'm savoring the moment of filling in a chart. Best summer ever. Filling in charts instead of surfing. It's okay, I'm going surfing in August. Actually, I'm going surfing in 2 weeks. Not even 2 weeks, I'm going surfing next weekend. No,
Where?
you're crazy in the head.
Where is it?
Washington.
Brenda Fernandez.
Yeah.
Where? Westport?
Yeah, by Forks.
Yeah. Oh no, I'm not going to Forks. But yeah, no, you're right. It's on the coast, just a little further down. I've been to Forks, but I can't take the Twilight stuff. It drives me up the wall everywhere. Twilight this, Twilight that. I don't even mind the movies. Even though I'm a boy, I don't even mind the movies.
Don't you eat with fork?
Well, there are also forks and rivers and roads and things, right? That's what the towns are named after. They're not named after giant eating utensils. But that place is called La Push. And I haven't been there yet, but it looked pretty cool. I know, it sounds naughty, right? La Push. Yeah. It's La Push. It's feminine. And we're in a French room. La salle de français. Ah oui, oui, je parle un petit peu de français. Ma femme, elle est bilingue. Elle est bilingue. Bilingue. No. Bilingue. Bilingual. My French is bad. I have a bad accent, but I know good French. Mon fils.
Comment ça va?
Ça va bien, merci. Toi?
Bien, no. I passed French with 52%. So
Oh, 52.
I don't think that's 52.
Oui. Okay, moving along. All right, now you guys aren't stupid? Do you think that fractions or decimals, do you think the rules change?
No.
No. It is still the number times itself. But here's where it gets weird, okay? We are only going to talk about fractions or decimals that are less than 1. Okay? So we were talking about fractions between 0 and 1. Everybody cool? So what is the easiest fraction between 0 and 1 that we all want to talk about? 0.5, a half, absolutely. So a half is less than 1. Everybody agrees, right? Now, normally, like I said, if you do a square, you get a bigger number, don't you? So let's see what happens here. What's the square of 1/2? That's 1/2 times 1/2, yes? What's 1 times 1? What's 2 times 2? 4. What? A half squares to a quarter, it gets smaller? Yes. Everybody understand? Only with these. Only when it's a fraction. Once you're greater than 1, the numbers get bigger. Cool? So what would 1/3 squared be? Yep, 1/3 times 1/3, which is 1/9. So we've covered fractions. Are we cool? What if it's not 1/3? What if it's 2/3? Do you think anything changes? No, of course not. 2/3 squared is 2/3 times 2/3 to get what? 2/9? 4/9. Everybody good?
Yep.
Okay. Excellent. What if it's decimals? Same thing. So we'll use 0.5. That's going to be 0.5 times 0.5, isn't it? Well, when we multiply decimals, do we care about the decimal until the end? No. So what's 5 times 5? 25. And I need 1 decimal, 2 decimal. So 1, 2. Got it? Okay. So what's 0.3 squared? 0.3 times 0.3, which is 9, with how many decimal places? 2. 1, 2. What goes in the hole? 0. Everyone see how it works? People have a lot of trouble with that one if they have to fill in that blank. Everybody, just like a day, wanted to say it was 0.9 because 3 times 3 is 9. But you got to remember, it's got to have the decimal. Everybody cool? Yeah?
Yeah.
Okay. All right, so now, finding the square given its square root. Right? So, the square if you know the root. So, read this question to me. You don't have to read out loud. Duh, we're in the 9th grade. 10th grade, at least. Calculate the number whose square root is. Do you have a root or do you have a square here? Read the question. That's a root. So what do you have to do? If you have a root, what do you do? Times it by itself. So because this is a root, this is a root. So what do I got to do? I got to do 5 over 8 squared, which means what? 5 over 8 times 5 over 8. 5 times 5 is 25, and 8 times 8 is 64. Everybody got it? That's how easy it is. Do you think the rules change with decimals? Of course not. This is a root, which means I got to do the root squared to get the square, yes? So the root is 1.2 squared, which is 1.2 times 1.2. What's 12 times 12? 144. And how many decimal places do I need? 2. 1, 2. So it goes right there. Is everybody good? Okay. Now, let's take a moment and show you how this works on your calculators. Most of you know, but I want to make sure. So everybody grab your calculator, whatever it may be. If your calculator is like mine, it writes down on the screen what you have pushed as a button. How many of you have a calculator that does that? Okay. If your calculator writes down the buttons you push, all of them, not just the numbers, then you've got to do your square rooting the way that it is written. So I would do the square root 64 equals, and I get 8. Everyone can do that, yes? Even if it's a decimal, you do the same thing. So if I go square root 1.44, we know it's going to be 1.2, yeah? Equals 1.2. Everybody good? If your calculator doesn't do that, it's backwards. So you got to hit the other way around. 1.44, then the square root button. And you probably won't have to hit equals. Does anybody have a backwards calculator? Okay, so you just got to remember you got to go the other way. Okay, everybody cool? Now, to square, everybody look around on your calculator. Make sure you see this button. A little X with a 2 by it. You may have a button that looks like this. I'll draw it on the board. You may have this. A blank box with a square. Does everybody see that button? That's what you're going to use to find the squares. Okay? Now that one works the same for both calculators. You're going to go 1.2 squared, or 1.2 in the x squared button, and then equals. And there it is. Is everybody good with using their calculators? Yeah? Okay. Now, of course, not everything is going to be a perfect square, is it? What happens if you take the square root of 2? So I want you guys to get me the square root of 2. Using your calculator, whatever it is, however you do it, tell me what the answer is. Then you punch it in wrong. Right. It's a big, ugly number, isn't it? Square root 2, damn. Square root 2 equals 1.414213562. Is that a rational number? No, because it fills up the whole screen and it doesn't repeat. All right? So if you are finding square roots that do that, then I only want 2 decimal places. So 1.41. Everybody with me? So what's the square root of 3? Use your calculator. 1.73, right? Square root 3 equals 1.732, so it stays at 7.3. Everybody good? Okay, so now everybody can do all this on a calculator, and if they're perfect, it's easy to do in our heads, yeah? Everybody good? Sweet. So you guys should be able to fill that in your sleep, right? The first 2 you should be able to do in your heads, actually the first 3. But I bet D you're going to need your calculator for. 3 times 3, 8 times 8, so it's what? 9 over 64. So 3/8 is the square root of 9 over 64. 3 halves times 3 halves. 3 times 3 over 2 times 2. 9 over 4. 9 over 4. Everybody cool? Fractions don't matter. We follow the same rules. 0.5 times 0.5, we've already done that. It's 0.25. Now, here you're probably going to need your calculator. So, what is it? 6.25. Okay, now I want you guys to notice something about decimals. Did this have a square root? Yeah, we just did it, right? Right?
Yeah.
How many decimal places did it have? 2. Did this have a square root? How many decimal places did it have? 2. Did this have a square root? How many decimal places did it have? 2. What does that tell us about, does the number of decimal places affect whether or not something can be a square root? Yeah, it does. It has to be an even number of decimal places if it's going to be a perfect square root. Why? Can anybody tell me why? It was supposed to be crickets. Why are you like that? Nobody can tell me why? What is a square root? What do you do with a square root to find a square? Multiply it by itself, right? So, if I go 0.2 times 0.2, my answer has to have how many decimal places? 2, doesn't it? Because it's 0.04. Correct? Everybody with me? So once I do multiply by itself, I got to count both decimal places, don't I? So it has to have at least 2. So the question then becomes, is it possible for this to have a square root that's perfect? Yes or no? No, because it's only got 1 decimal place. Everybody with me? Cool? Now, watch what happens if I do this. What if I do 0.02 times 0.02? What's the answer? 2 times 2 is still what?
4.
But how many decimal places do I need now? No. 1, 2, 3, 4. I have 4 decimal places, so it can have a square root. Everybody with me? What's the next possibility? 1 decimal place, 2 decimal places. What would this one be? 3 decimal places. So that would be 4 again with how many decimals? 6. Everybody cool? it has to have an even number of decimal places if it has a chance of being a perfect square. Because there's no way to make an odd number of decimal places, is there? Everybody good? Okay. Is this a perfect square? There's two ways to check. The first thing you could do is make it a fraction, or make it a decimal. How do I make this a decimal? There's two ways to go. The first one, you could do 16 divided by 25, which gets you what on your calculator? 1.5625. Is that an even number of decimals?
Oh, yes.
Yeah, it is. So is it possible this is a perfect square? It's possible. So we would check. Then we would take the square root of that, and what would we get? So I go to my calculator. I'm going to go 16 divided by 25 to get our decimal. Right? What? It was 16 divided by 25. You're killing me.
Oh, 0 point.
It's 0.64, you crazy man.
I think I did the bunch.
Does it have an even number of decimal places? Yes. So it's still possible it's a square root. So then I take my square root of 0.64 and I find that it is a perfect square because the number ends, right? So it's 0.8. That is one way to do it. You can make it a decimal, then square root it. The other way to do it, the second way, is this. That's way one. Way two is you do this. 16 over 25, and you check the square root of 16 over the square root of 25. Does 16 have a square root? What is it? 4. Does 25 have a square root? What is it? 5. So that's the other way to find a square root. And of course, if you do 4 divided by 5, you get that it is 0.8. And they are the same thing. Picking up what I'm putting down? So let's look at this one. Which of these is easier to do without a calculator? Way 1 or way 2? Way 2, especially if you know your square roots, don't you? All you got to do is check. Square root of 9 over square root of 20. Does 9 have a square root?
Yes.
What is it? 3. Does 20 have a square root? No, because 4 times 4 is 16 and 5 times 5 is 25. Nothing in the middle. So this doesn't exist. So this is not a square. Does everybody understand? This is what we call an irrational number. And we've already talked about rational numbers. These are the irrational numbers. Cool? Well, not so much the ugly cousin, just the other side of the coin.
So it's heads.
Or it's heads. In case you weren't actually here, I did a mind-blowing gesture there. So if you're watching this at home, you'll want to know that now's the time to laugh. It's kind of like when you put on described video on your TV. Have you guys ever had that happen by accident? Well, you know what closed captioning is, right? Where they write out what the characters are saying. Well, you can also get described video if you're blind. So you're watching the TV show, and you're watching it and seeing it happen, and everyone's talking, but then in the background somebody else is saying, the teacher just got up and walked to the board. So if you're blind, you can still watch TV. Wait, sorry, blind.
Listen.
If you're visually impaired.
Yeah, they don't like being called blind.
I know, we covered this.
Yeah,
Yes, because I had my friend that was the blind winger.
yeah.
Yeah, but he was only legally blind, but it didn't sound as good to say he's the legally blind winger. Okay, so let's do this. 9 is or is not a perfect square? Is. Why? Because 3 squared equals 9. Is 49 a perfect square?
Yes.
It is, because 7 squared equals 49. So if both numbers are perfect squares, then is the fraction a perfect square? Yes, it is. 25 is or isn't? Is, because 5 squared is 25. 13
No.
isn't. Why? Because there's no equal factors. So 25 over 13 isn't a perfect square. Is everybody cool with that?
Questions like this on our quiz.
Not on your quiz. Well, kind of like this, but a little different. What about this one? You guys fill this one in. Is 8 squared, is 9 squared, and is. Cool? Now reverse it. Go the other way. Square root of 9 is 3 times 3. Square root of 4 is 2 times 2. So what number goes here? I want the square root. So the roots are the factors. What are the numbers? 3 and 2. Yeah, because 3 over 2 squared is 9/4. Cool? So what about this one? What goes in the top? 4 times 4, and in the bottom? 9 times 9. So what's the square root of this guy? 4 over 9. Everyone see how easy it is? It doesn't matter what we do. If they're both squares, it's got a square root. Cool? We're almost at break, and we're at the end of our first set of notes. Is each decimal a perfect square? How do you know? Does that have the right amount of decimal place? Is it possible? Yes. So this is possible because it has even number of decimal points. What about this guy? Is this possible? No, this is impossible. Why? Because it's got an odd number of decimals. Now, we're halfway there. Is it a perfect square? It might be. How do we check? 2 ways. We can use our calculators, right? Go square root 1.69. Or we can check with math. 1.69 is the same as 169 over 100, yeah? Right? So we take a square root. So that would be the square root of 169 over the square root of 100. What's the square root of 100? 10. And then you would check that with your calculator, or you would memorize it, because like I said, it's good to know up to 20, and you would find that as 13. Is that a nice, pretty fraction? So it's got a perfect square. So we were right. This guy would be 35 over 10, wouldn't he? Right? Does that work? No, because 35 is not a perfect square, and neither is 10. Everybody cool? Yeah? Okay. We are going to stop there for now.